Today we are working through slightly more difficult trigonometric expressions. And I see Logan has taken out his sheet of notes, this nice little sheet of formulas here. You guys are going to want that, kind of. And the first thing we want to recognize that we have tangent squared over secant minus 1. And I do not have a formula here for secant minus 1. I have a formula for secant squared minus 1, but that's different than secant minus 1. Some people will say, well, if tangent squared is secant squared minus 1, then secant minus 1 must just be tangent. No, that's not true at all. And so we're going to do something different in this scenario. I know that in the previous ones you guys got used to substituting something in, but what we're going to do is we're going to kind of do it differently. We're going to substitute, instead of something for secant minus 1, we're going to substitute something for tangent squared. We're going to substitute this, secant squared of theta minus 1 over secant of theta minus 1. Those look almost the same, don't they? And one great approach as a mathematician is to sometimes model it with an easier problem. So that's something like x squared minus 1 over x minus 1. See how those are really the same? Well, how would you simplify x squared minus 1 over x minus 1? Very good. MSE is to factor x minus 1 times x plus 1 over x minus 1. And you see the x minus 1's cancel. Well, secant squared of theta minus 1 is the same as secant of theta minus 1 and secant of theta plus 1, all over secant of theta minus 1. Those cancel, and I get secant of theta plus 1. Parth, do you have notes? Parth, welcome back. We are very excited.
Yeah, how long were you gone?
There are your notes.
I mean, we were only in school probably like 4 days.
So our YouTube Nation, one of our colleagues is back. Parth took a little visit to India. How long again was the flight? 15 hours. So good for you. Nice job. Yep, that's a lot of movies. that's the Lord of the Rings trilogy a couple times through. All right. Cosine of theta plus 1 over sine squared. And sine squared, I'm going to plug in 1 minus cosine squared. And the whole time, you got to kind of look ahead. You have to be able to look ahead and say, well, I'm going to be trying to get this cosine of theta plus 1 to cancel. Well, now you see that the bottom factors, doesn't it? What does it factor to? 1 plus cosine of theta, 1 minus cosine of theta. Is cosine of theta plus 1 and 1 plus cosine of theta, are those the same? They are the same because addition is commutative, so therefore you could just cancel these two off, leaving us with 1 over 1 minus cosine of theta. That's the answer. You are going to desire for me to give you a way to solve these every single time. So it's like, okay, this is kind of the steps that you take, and I can't give you that. You have to recognize relationships. It's challenging, and that's okay. What do you think I should do for C? Distribute. Now, there's a reason why distributing is a good idea. I'm going to glance ahead before I even write anything else down. What is secant times secant? Well, that's good because when I get squareds, I can substitute things in, can't I? And what's the relationship between secant and cosine? They're reciprocals. When you multiply two reciprocals, you get 1. Well, squareds are good and 1 is good, right? So this looks like a good option. I get secant squared of theta minus 1. Shoot, if I only knew what secant squared minus 1 was. We do. What is it? Tangent squared of theta. That's the answer. With the next one, I can multiply sine through. Sine times sine is sine squared of theta. What's the relationship between sine and cosecant? They're reciprocal. So when you multiply them, you get, or 1 cosine squared of theta. Shoot, if I only knew what sine squared plus cosine squared was. It's 1. There's something happening inside of you that says, I know that sine squared plus cosine squared is 1, but I have no idea why. Do you? When you do want to know why, let me know. I'll give you a 12-second explanation. What is this? Circle of life. What's the length of the radius? 1. This is a point, x, y. Which is y? Is y the sine value or the cosine value? Sine. How about the x value? Cosine of theta. Hey, this is a right triangle. What do you know? Sine squared plus cosine squared is, which is 1. How do you like that? There's a little proof for you. All right. How about letter E? What do you want to do now? Let's just multiply them all out. So I get a 1. I get a plus cosine of theta. I get a minus cosine of theta. I get a minus cosine squared of theta. Well, what happens to the middles? They're gone. Yeah, remember, these are conjugates, aren't they? So the middle's always going to cancel when we got conjugates. So we get 1 minus cosine squared of theta. Shoot. Wonder what that is. Hey, it's sine squared. Look at Ashley go. Way to go, Ashley. Yes.
Like this side, yeah, maybe, but this side.
All right. Here we go. Tangent plus secant times tangent minus secant. What are you going to get? Tangent squared of theta minus secant squared of theta. The middles are just going to go away, right? Yeah, so Sam's multiplying it out. Sam, you're doing exactly what you're... No, Sam, you're doing exactly what you're supposed to do. You get that positive tangent secant. You get that negative tangent secant, right? But we know that they're going to go away because they're conjugates. Well, what's tangent squared minus secant squared? It's not 1. Look. See how we have 1 plus tangent squared equals secant squared? What happens if we subtract 1? Well, then we get this, right? And then if you subtract the secant squared from both sides, you get that. So see how I made a new formula that wasn't up on our sheet? Tangent squared minus secant squared is negative 1. Sure. You guys see how I got the new formula, right? So you can add, subtract, move things all around all the time. I mean, it all came from a squared plus b squared is c squared. That's where all this stuff comes from. And you could just manipulate all of them to get all sorts of other stuff. What about letter G? So I get 4 secant squared of theta. What's going to happen in the middles? Why? Because they're conjugates.
And then we can take out a 4.
Factor out a 4. Thank you, Samantha. If only I knew what... Jeez. Man, I don't think I ever said that to one of my teachers. Stop teaching us. We already know. All right. Okay, Sam, just lead us. What do you want?
Well, we know that is.
Oh, my gosh. Oh, I'm done. 4 tangent squared. Yeah, you were confident enough to say it. 4 times tangent squared. So you've seen some great examples so far, but these are the strategies we've given you so far. Number 1, change things to sine and cosine. Number 2, substitute something in. Number 3, multiply. Number 4, factor. But the fifth option to simplify trigonometric expressions is to take two fractions and make them 1. Now, in this situation, you don't see it. You're not like, oh, well, how is that two fractions? I'm going to show you. Let's make it into two fractions. Because I don't see a squared there. I don't see a 1 there. I don't see anything that cancels. So I'm going to write this as cosine of theta over 1 times sine of theta over cosine of theta plus cosine of theta over sine of theta times cosine of theta over 1. How do you like my work? Last hour, it told me to slow down because I was moving too fast. So cosine is just cosine over 1. Tangent is sine over cosine because of all that stuff. Yep. Now, now she's feeling judged and not safe. So, all right, here we go. So those are going to cancel, right? Now, it's really important, folks, that you recognize something else. We want to cancel the signs, but we have addition. So are the signs going to cancel? No, they're not, are they? Right. So that's an excellent thought. Excellent thought, like the factor label thing in chemistry. Thank you. Okay, so we've got this. What I really wanted you to recognize, what I really wanted you to see is that the cosine squared pops up. See, it's good to get a cosine squared, isn't it? Because we like squares. Oh, what do you notice now? Oh, so I find common denominators, sine of theta times over sine of theta. Then what happens? Whoa! Do you see that? So now I have sine squared of theta plus cosine squared of theta all over sine of theta. And Ashley says sine squared plus cosine squared is 1. So I get 1 over sine, which is cosecant. You guys are awesome. Oh, Marty just gave a nasty look. Okay, all right, okay. Early in my teaching career, I was doing a problem, and I had a student shaking their head in class. And I'm like, what? And they're like, that's just a bunch of garbage. And I was in a really bad mood. And I'm like, you want to see garbage? So I walked up and I took all their homework and their worksheets. I just ripped them up and I threw them away. And I took the kid out and I just reamed him. I just said, you don't call anything I do on the board garbage. But I was having a really bad day, you know what I mean? I just lost it. I wouldn't. I was definitely below the line. It's definitely below the line. So, yeah. Yeah, I've grown as a teacher since then. I don't often do those. So, yeah, yeah, yeah. No, the kid I did that to is a really nice kid. Actually, we that was a stepping point for us in our relationship, student teacher. So, yeah. All right, here we go. Sine squared times secant plus cosine. Similar type of problem. I'm going to write it as sine squared of theta over 1 times 1 over cosine of theta plus cosine of theta over 1. What do you like? The sine squared. We like the sine squared. What would be nice to have with the sine squared? A cosine squared. Is there a way to get a cosine squared? Multiply the top and bottom by cosine of theta, then they would have a common denominator. And I get sine squared of theta plus cosine squared of theta all over cosine of theta. Exactly. It's the same type of problem. I just rewrote it a little bit differently. This time we get 1 over cosine, which is secant. Does somebody have time for us for when we get out today? I got to make sure we. Okay. All right, we'll make it. How about letter J? This is a problem where if you guys approach this right now, everybody should be able to work through this one. You tell me a strategy. What do you want to do? Good. Good. 1 minus cosine of theta over 1 times sine of theta over 1 times sine of theta over cosine of theta. Oh, yeah. Something lodged in my throat. Okay. Yeah, we've seen the Office episode enough. Staying alive, staying alive. All right. Professor was afraid. I was petrified. Yes, awesome. So what do I have? 1 minus sine squared. Awesome sauce. Yeah, if we could take the test as a group, including the teacher, it would be amazing. One of the best quotes of the year, and this should come up every year, and it's taken so long for this quote to come up, but somebody last hour said in class, they're like, Mr. Gentz, like I get all of the assignment when we're doing it together in class. When I start to do it on my own, it just all falls apart. Like that's totally normal. Folks, if you're able to roll through the assignment, just get each one right away, that's I would say 1 out of every 100 kids can do that. It's totally abnormal. Okay. Every YouTube, everybody's raising their hand saying, I'm that kid. So don't be surprised if you get one wrong. You got to go back to it over and over again. That's normal. Yeah, crying. All right, letter K. We've got no squareds. It's a bad thing. We've also got fractions. Frustrating thing. So what do you think I'm going to try to do? Common denominators. Thank you. So we're going to do sine of x plus 1 over sine of x plus 1. Noah's like, of course I'm right. People don't look surprised. Is what's never happened before. And Noah's surprised myself. So we're going to multiply top and bottom by cosecant of x plus 1 over cosecant of x plus 1. And the other side by sine of x plus 1 over sine of x plus 1. Cosecant of x plus 1, right? Plus sine of x plus 1, right? And we could combine the 1 and the 1 to make 2, right? We could. And sometimes it's good to leave the denominator factored, and other times it's good to multiply it out. So I'm going to show you as it's factored right now. Can we just go ahead and cancel off these sine of x plus 1s and these cosecant of x's plus 1s? Can we just cancel those off, get rid of them? You can't because you got the addition thing, right? So you can't do that. And so I don't see anything that cancels. So at this point, we've really got two options, and they both work. Number one, you could rewrite the cosecant as 1 over sine and then make a complex fraction, and that's a lot of work. Yeah, the conjugate piece, there's actually about 5 or 6 different approaches to this problem. But the easiest one right now is to just check to see what would happen if we multiplied out the denominator. So let's multiply out the denominator, just see what we get. What's cosecant times sine? What's the relationship between cosecant and sine? They're reciprocal, so when you multiply, you get 1. Then you have cosecant times 1 is cosecant. Then you have 1 times sine is sine. And then you have 1 times 1 is 1. Are those the same? They are the same. Right. Noah brings up a great point. If you write 1 and put a box around on the test, there's a good chance that you got the right answer, but all your work must support that answer. Okay. All right. Final example. What should I do first?
Common denominator.
Good. So I have 1 plus cosine of x, and over here I have cosine of x over sine of x. You guys said to find common denominators. Cotangent is cosine over sine. Yeah. Yeah.
I'm sorry, Maddie.
Now what?
Now common denominator.
Is that going to help me as I'm writing this? Is that going to help me? It will. Why? I get a sine squared, don't I? And then if I multiply over here, 1 plus cosine of x, am I going to get a cosine squared over here? Yeah, I like that. I like it when I get sine squareds and cosine squareds and tangent squareds and secant squareds. It's all good stuff. So I have sine squared of x plus cosine of x, because I got to take the cosine times both those pieces, don't I? Cosine of x plus cosine squared of x all over sine of x times 1 plus cosine of x. So I'm not going to multiply the bottom together right away because maybe something will cancel. Well, what simplifies up here? Sine squared plus cosine squared is 1. So therefore, you have 1 plus cosine in the numerator. Yeah, 1 plus cosine of x in the numerator. And the denominator is sine of x. Hold on, 1 plus cosine of x. Notice that those cancel, and we get 1 over sine, which is cosecant of x. You are now capable of finishing that entire assignment. It is not easy. I just finished the answer key. I also posted online. I have at least one student who's going to pop in today after school to ask questions. Not uncommon for me to get double digits for students during this unit who want to pop in and ask questions. This is tough stuff, folks. So, but fortunately, you are extremely intelligent.